Okay. Hey, everyone. Thank you for joining me. Today, we have a very special guest. I'll introduce Hubert in a second. This is our 79th meetup, getting close to 7 years. So, in few months, we're going to be 7 years of this group since the inception. That was March 2019. So, getting very close to 7 years, which it's, uh, it's a big milestone. Uh, it's not easy to maintain that. I'll tell you that. Um, sorry, I'm posing sometimes because the people coming in, so I need to admit them one by one. So sorry about it. Okay, so let's do it fast so our speaker can start his talk. So just a reminder, we are here every month. If you have anything that you would like to discuss, please do it. Come over, approach me. I'll accommodate any subject, any topic that you would like to discuss. So there's so many things, and doesn't need to take everything, the entire 50 minutes or 55 minutes or just anything. Just let me know. I'd be more than happy. Um, as of today, we might be one more. I think I admitted like one or two more today, so we about 1,862-ish, or maybe three, four. Thank you, JetBrains. So JetBrains is sponsoring our San Diego Superpass meetup. Thank you, JetBrains. I love your IDEs. So thank you for sponsoring us. Okay, let's jump to the agenda. Cracking open the black box. Legally testing the privates in C++ by Hubert. Before I introduce Hubert, I just want to give a small story. I came across Hubert. We just recently start discussing, but I'm using Hubert library many years ago. Started in Qualcomm, and also in NVIDIA. I'm using his library. So we just connected recently, and he generously offered his time. We appreciate that, and so here we are. And let me just introduce Hubert. He is a lead software engineer with over a decade of experience in C++ development across automotive and robotics, focusing on performance critical and distributed systems. At Apex.ai, he worked on automotive grade software defined vehicle frameworks, and he is currently working at Here Technologies on maps and rendering in large scale C++ projects. By the way, I worked in automotive in Qualcomm, and I remember we used Here at some point. I don't know if still using that. I'm not in touch with anyone there, but I remember Here was a big thing. His current interest also includes Rust, and I would love to hear about that as well. Its application in high performance and distributed system. Welcome, Hubert. Very glad to have you.
Yeah, glad to be here. Thank you for having me. Yeah, so let me share the screen, maybe. Hope everything will be right. Hopefully you can see the screen, I guess.
Yeah.
Okay, so small disclaimer. This is kind of funny because as Scobie said, he was using the library. I had literally no idea that anyone is using that. I just created that out of kind of a sheer, wanted to check something that I found out in the standard. Then later on, I discovered that it's not me that found it first, but there is another guy who did it, and then there was a mailing list and client later on. I discovered it was done the same way, but the point is that I didn't know about it, so it's kind of reinventing the wheel. So I didn't even know that there is anyone using the library. I had a meetup local in Poland like 8 years ago. So this presentation is a little bit defrosted. We are coming to Christmas probably alongside Mariah Carey. It was defrosted as well. Yeah, so I've tuned it up, and here you are. So I'll speak about accessing privates, and that may be a little bit controversial, I would say, because this is the first thing you don't do when you start C++. You have an encapsulation, and they tell you have privates, publics, protected. Just don't mess around with that. You just create a code in the way that it should be done this way. So why do we even do that? Like, I've created a Reddit post back 8 years ago and about the library because I thought it's kind of fun. And the first comments would usually be, hey, why you even do that? Just don't do it. And that is true for most of the cases. But I would say in the perfect world. So in the perfect world, there are few things that you have that you shouldn't be doing that. You have a good design. You don't have anything, you don't rely on any stuff that is legacy, third party. You can build everything from scratch and you can just do whatever you want and you just do things correctly. And also you have infinite amount of capacity because sometimes the refactor just takes time. So if you have all of that, you can just disconnect and you don't need to use that anyways. But the life isn't like that. So in many cases, you have a legacy code base. There are just the design is not that great, but you still need to have the test for it. Or you might have a third party. You cannot really change their source code, or you have even them pre-built and you are not actually building them yourself. Or you need to do the refactoring. So you say, hey, maybe I'll just change my code, but you still need to have some tests to have like the first round, then change the test, and then rerun this test, and maybe then refactor them alongside. Or in, as I said, as Kobe said, I was working in automotive. I am working in automotive, also robotics. And then in many cases, you have certified software. And certification of a software is really hard. You need to tick a lot of stuff. And then if you need to change that software that you rely on to access something, you cannot really change that because that would, kind of avoid the whole point of it. So you need to work that around. Or as usual, you have very bad timing and you are actually certifying your software and you cannot really have another month or a week or 2 weeks or whatever to redesign your stuff from the ground up to make it testable. Or actually, you are trying to create some serialization or Python bindings. So that was 8 years ago. Right now, we're going to have reflections in C++26, which kind of would make it happen for you. But again, probably some of the domains will use the fraction maybe in 10 years or so. So in all of that, you might be kind of thinking, hey, I can use the privates. How to do that? But you might say that, okay, but this is already doable. There's tons of ways you can do that, and that shouldn't be too hard, should it? So there's really many ways to do it. Here are some of them. So you can use macros. The easiest would be you can just define some stuff. You can define that the privates are public, and kind of include the stuff that you want to test on, and that's it. There is some pointer trick with the interpret cast. You can cast it to the right value, access it, and kind of modify the stuff inside. You can do the pointer arithmetics, in which you just access the right value of the class. You just need to do the the right math, the arithmetics, kind of a shift the pointers that you are pointing to, and you probably access that correctly, which is maybe fine, but really be hard, and especially hard if you are doing that for something that is complicated. Then there is a type pruning. I haven't seen too much of that, but you can use a union with the values, and just with a placement new, you can kind of access the value. Yeah. So there is a pattern around all of that, and the pattern is clearly undefined behavior, which is fun. And as I say, like in the most cases, you probably won't see a problem because the compilers are super smart nowadays. So they would try to make it work despite you trying to abuse the standard. But they are sometimes smart to the point that they will just remove the code that you are trying to abuse. So if you are using some certain optimizations, or you have different compilers, you have different environments, then something can happen. Or you are creating a library that someone else will use, then he have a different setup, and that can just break. In best case, it is a compilation error. Worst case, it is a runtime error you don't know about, and this is just a huge pain in the back. So there's a lot of problems that can happen. In my experience, I've seen that using defined private public is probably the most common. Like I've seen that a lot. Actually, the whole purpose of that library was because back in Intel we were doing something like that because lack of capacity in something. And actually, I hit one of those problems, which was a layout corruption back in 2020, 2015. And I kind of started digging, and yeah, I found that loophole in the start that I will talk about a little bit later. Okay, so out of the most kind of a common stuff that I was able to find right now would be a marker leakage or one definition rule violation. So that would be a different transition units, a different class definition. So the define just leaks inside of all of the includes that you have. Or that might be a layout corruption that I said. So you might have just a different sizes of the classes. And that happens because if you reorder the members inside of the class, there might be a different padding, and different padding can, make the alignment incorrect, and then you can have a different size. Not so common, but that can happen, and yeah, and that can be a big problem. And there's all types of the stuff that is based on concepts or tag traits or HDI, in which you just have, different resolution of the stuff that you want. I've created examples for all of them. So this is a marker leakage. Just remember maybe a little bit about this one. So we have super simple class JSON parser using the kind of very, very popular JSON library, and we just get some value of it, and we have a private data as well. So I'll be using Godbolt a lot. I mean, I have Windows machine right now. Let me know if that's not too small. I can make it a bit bigger.
Looks good.
Okay.
Looks good. Looks good from here.
Okay. So yeah, let's say we have a situation like this. So this is exactly that. Super simple, single private, some public function, and of course all the examples that I was showing are dummy a little bit, but they are showing the problem. Real life, that would be more complicated. So I'm using that from my GitHub. I know that Godbolt is having this source tree, but I didn't want to fiddle around with that. Let's say we are using that, right? So we have some JSON, get the value, right? So let's say I need to, of course, access the private. That would cause this to not compile because we are accessing private, obviously. So let's use the easiest solution. That would be this one. And this is kind of the best case you might have when you are having problems with privates. You have a compilation problem, which is good because you can just fix it. So the problem is that whatever you define here also get leaked inside of this JSON parser header, and then all of the stuff that is inside of the JSON parser header is included is also leaked inside. So you have all of this matryoshka of things that happen, and you have just one definition rule broken, because then some of them are redeclared. And this actually, when I was checking, happened to that very same library that I'm using. In 2019, they just used it for the tests, and out of a sudden, when they tried to use a newer testing framework, it didn't work. So that would be okay in that sense, but if you are creating a library like this and then your user are getting compilation error, then it's not really the greatest. Open source can fix it, but if that's production, not so great. That tests are actually creating your stuff to fail. The other one would be a layout corruption that I said before. So it's super simple. And by the way, how they fix that on the short term, they've created another UTF that would be private unless in tests, and use that instead of privates. So I said, okay, I'll be using that for the remaining of this presentation, and I'll show you that it still can make your things break. So here we have very simple classes, some inheritance, and then let's see what is the size, both of them. So one is defining it, the other one is not, as you can see. And as we can see, they have different sizes. So if you are using that, so you may say, hey, but what's really the problem? This is tests, I'm gonna see that, and most probably if that will be something like a serialization, deserialization, then in most cases it will happen so that you will build the test, the serializer and deserializer with the same code, so you will have the same sizes, even if you are doing some, size off. Okay, fair. But what happens if you not do that? You have the deserializer fixed or already built, and you are using that. Then, worst case, best case, you have a compilation error, or you have this maybe not compilation. You have test failing, and you can see, hey, the Abbey is broken. We are not talking the same language, and just fix that. Worst case, you fix the test to work because whatever, and then the production doesn't work. That might happen, because this is life. I've seen that, unfortunately, and this is super easy example of that. So this is what I'm saying. The code is not that relevant, but we are kind of serializing that and deserializing that, and the values, of course, are different because we have different sizes of them. So that can really be something easy to fix. Either you have a night to fix or a day to fix the test, or you have a production problem that actually can happen. Okay, then the type trait inconsistency. For the remaining, all of that is in Goldbot, so I will skip the slides. So again, a little bit simple example. We have some message. We have a type trait that checks whether the class has a serialization method. Then we have like a policy. One is that we are actually using the serializer. The other one is we are using something that is just a fallback strategy, I would say. So in the first, of course, this is a very simple example, but something more sophisticated had happened. So here, the type trait once works and once doesn't, because the public is right now the private is now public. So sometimes it just can give you a false positive, and that simple case can give you a different result, which can be nasty to find out what's going on, especially if the templates are really hard to read. And okay, you can say, how about concept? Maybe concept are better in that sense. Not so much the same kind of a structure. We have a concept that checks has a serializable or is serializable. You have the same result. So you just end up with a mess that you need to find out. The last one I thought about was the RTPI. So it was hard to find a short snippet of a code that would show you that the real, let's say, a plugin example in which probably the RTPI is used. But let's say you have some interface implementation, maybe a plugin, and then for whatever reason, it's not that common right now. In the modern code, you have a private inheritance, and then you are just using the dynamic cast out of that. So in one example, that will run, and the other one it will fail because you just leaked the public, and everything is public right now, including the inheritance. So it is breaking the whole of the stuff. And if someone is not really used to kind of knows a lot about C++, that would be a hard one to find out. Really, really nasty stuff. Yeah, so a couple of hours I wasted at least, I would say. So those are the main problems that I thought. So what if I told you that the private was all aligned from the beginning? So as I said, there is a loophole in the standard. So first thing you learn about C++ is the encapsulation and so on and so forth. And they tell you, hey, if you access the private from whenever, you either break the standard or we're gonna hit you hard in the face, right? But they do, but they are inconsistent. So to me, this is like a parent with a kid who is in the car. You can't have cartoons, but unless we are driving a car very late and I don't want you to, kind of go to sleep, and then you can do that. So There's one tiny element in the whole standard, maybe there's more, but I found this one about explicit template instantiation. So the explicit template instantiation is used when you need, because when you are using templates, then the code is generated when they are actually used. But there is one way when you need that is you can tell the compiler, hey, I want this type to be upfront generated for you. And then that will be accessible and we can check that. And with this stuff, they say this little line. So explicit instantiation definitions ignores member access specifiers all along. You can do whatever you want, like totally free. Parameters can and return types may be private. I will not open that. There is a link. If I will share the presentation later on, so you can check that this is not a lie, actually. Yeah. So this will be a live coding. I'll just go over the case. And this will be actually live coding. So be prepared that something will fail. I'll be thinking how to fix that. I'm not lying. Whenever I've been presenting that, it was never 100% working from the very beginning. Okay, we have this situation. So let's say there is a simple class foo that has bar, some string in it, private function, and the public function. And I want to cover two use cases. One of which would be, I want to actually access this private int. I want to change it, and I want to access it again to see that the change I've made is actually happening. And the other one would be that I'm using the public interface to show the string. I want to change it using the function that is private, and I want to show it again. Okay, so I just told you that there is a loophole. Let's say for the beginning, let's assume I didn't say that. Okay, so how do you approach that? We are approaching that from the very beginning. Let's maybe have something dummy. Maybe member bar or whatever. Okay, and that's gonna fail, of course. Maybe let's do it like this. Yeah. Of course, that's gonna fail because, as I said, standard says you cannot do that outside of the class that you are defining because that's private. That's fair, but we still need the type. So we could do that by creating a pointer to the member, to the class. So that would be type of the thing that we want to access, and then a class that we want to access, pointer. And that would be the type that you can it is compiling? No. What I did. Ah, yeah. As I said, this is really live coding, so I will be making mistakes. Yeah. Okay, so this is actually a type that we would be able to access if that would be public for a moment. Okay, so anything that is crazy about C++ is connected with the templates. We already know about this loophole that would be a template. So let's try to create a template that uses that. And for the lack of a better name, let's call it a wrapper. That would be a wrapper that would allow us to access stuff. Okay, and that should be fine because right now we are not using the reference to that member, and it's the compiling, but it should be fine. Yeah. Then, if you would like to, of course, access it, that wouldn't work because that's private. Okay. Wrapper. Yeah, it's private. Okay, then right now, let's use the loophole as I told you about. You need to use that as a template class, the name of the template, and the thing that you want to make specialization with, core. Okay, so I wasn't lying. This is actually the case for the standard. It works. You can do stuff like that. It's not very useful for the moment. Yeah, but you can still do that. So let's think how we can, because right now it does nothing. We need to assign that to some value. So what we would need to do is to have some value and assign, I don't know what yet. Before we do so, I would like to get rid of that because we have two use cases. Actually, we should have three, but for the case of this presentation, we have two. One is that accessing a member, the other one is accessing a function. So let's create some helpers, one which would be a member, the other one would be a function. So the member, as I said, we need the type and we need the class, right? Let's have it this way. And then we can have some type. And the type would be the type of the member and the class that we are accessing. That should be fine. And hopefully, and the same stuff will come for the function. But for the function, we need to have a return type. We need to have the class to access to. And we also need to have the arguments that we'll be using. So this is a super simple example. It should be done probably better, but for the case of this, let's use the simplest way of making it. Right, that would be a class and an arguments that we need to pass. Okay. So far so good. Then we don't need this anymore. And for that wrapper, what we need to do, we need to have the type that we want to access and the value that we want to assign to. That would be t. And also, we already defined the type. So we can say the t type would be this pointer to value. And here we have, let's say, this value. The value will be the thing that we assigned. The type would be the one that we passed. Then everything is taking place in the compile time. That can be a context. And if that's a construct, then that should be static. And static is anyways needed for us. Right? Okay, so we have something like that. Here, we just need to pass that new thing that we created. Okay, this one is fine. But there is a slight problem about it. Because if we like to, let's say, show it, then you have the member, then the pointer, and then you have the wrapper. Then you need to have the type, the t, and also the thing that we want to assign. And this is a deal breaker for the moment because it's not going to work. Right? And that's not going to work, of course, because we are still using the private stuff. So let's think how we can change it. The problem here is that we need to get this one out of the equation, at least for the moment, I would say. So yeah, let's remove that. This is what I'm trying to achieve, at least now. Then that, let's comment it out right now. And here, this guy is no longer needed. Then cannot be context. We are not assigning anything anymore. And that is static. Okay. We have undefined undefined reference because this is static. So this is uninitialized. let's make it initialized. So the thing that we are accessing is a type, a T type, and we are accessing it inside of a wrapper. Okay, I guess that should be fine, at least for the moment. And it does work, but of course, there is nothing assigned to that, so this is just a garbage. Then comes a question, because what we want to achieve is that here you need to make some kind of a, actually need to make the wrapper to the point that you point it only here, then you assign this pointer and you forget about it. It's there forever. And that would be also, we'd like to make it simple. So this code is already a little bit strange. So let's not make it stranger. That should be implicitly called. So that should probably a constructor called automatically when you initialize the class. Yeah. So in terms to do that, let's, as I said, we need to make the wrapper. So let's create some structure that would be make wrapper. Right? And it needs to bind the stuff that we have with the pointer to the value that we had before. That would be T. And then the old one, value pointer. Okay, we have that. But it doesn't bring us any closer. So the case is we definitely need some constructor. And since those are templates, and probably we'll need to struct. So let's create something, let's say, called setter. And that setter will only have a constructor, right? That's the whole purpose of it. Okay. So then this is static. What we can do is probably access this static with the value of it, right? And then put this pointer inside. Most probably that should work, I think. It does work. But the point is that this constructor is never called. And to make it called, then probably we need to have some member. Let's say member setter, I don't know, make it work or whatever. Okay. Let's see. That still doesn't work. And it doesn't work because it is not calling the constructor. So the only way for you to call the constructor in C++ is that it has a static. So if that would be having a static, then that would be called. Okay. So let's have it as a static. Then let's change that to this one. Okay. Okay, it still doesn't work. And it doesn't work, and it is not obvious as before because this is static and we haven't initialized that. Right, so let's make it initialized. And then that would be what type name? The type is setter, and then the value, again, a lot of boilerplate. Right, we have the make it work, I guess. Yeah. Type name. Okay, I did something incorrect. Yeah, this one. Okay, and it does work. So a little bit of magic, and we were able to actually assign it inside of this template class explicit instantiation, and then we are able to make it work here. So let's maybe change the value. So it's maybe something more than just getting it, right? And then let's print it again. Okay, it does work. So the code is not that beautiful, but it works. So the first use case is done. Then we need to think about the second use case, because the second use case is actually accessing a method, a function. Okay, so before we do so, I'm not really fond of that. Let's make a little bit of an alias for it. So that would be struct maybe member bar. Member bar is this one. So we can inherit over it, something like this. Then we can just replace, sorry, it should be above. Then we can just replace all of the stuff that is just a little bit harder to read. Let's see, it still works. It does. Okay, and then for accessing the function, that would be the function is what called change foobar. So let's keep it this way. And for it, it would be old stuff that we created. That would be return type, class, and arguments. So void, foo, and std string. Right. Okay. This is done. Then we can do the same stuff for this one. It should be fine. Then those two, they are public anyways. And then for accessing, we'll need to be doing something like that. Then we are using this one. This is a pointer. So the function, so we need to have it like this, right? And I hope it will work. Yeah, it does. So we can access the function, we can access the member, and it does work. The code is not that beautiful, but it does work. But there is something wrong about the code. I mean, there's the whole lot wrong about it, but there is actually an error about it. I'm not sure if anyone noticed it. So the point is that currently we are using a pointer to a member, but we are not really specifying what kind of it is. So let's say we would have another int member that is private. That will fail. That will fail because we will be using one chunk of memory, and that will be overriding each other. So I'm not going to change it here, but what we can do is we could, maybe I'll just show a little bit. We could create a tag. So this one, I said that this is only for the case of the visibility. I lied a little bit. So this is also later on that we could make a unique tag. And if you have a unique tag for each of those, so we could have actually a member and a member. The tag can be the same as the structure that we are accessing that will be showing. That is unique because we created that as a struct. Then we can have a uniqueness. So if we add this tag to the wrapper, we don't need to do anything about it. And then the same for the make wrapper. That would work. So we could have the same functions, same signatures of the functions, same type of the members, and that will work, right? So this is a little bit of a caveat that is missing right now. That should work. Yeah, and as Kobe said, I've created a library that does that just for pure fun of it. And let's say we will use that for a month. So I'm using my own GitHub link to the GitHub. I mean, in Codeboard. So with the library that I did, you can either do that with macros or without them. The macros are here just because I could have just kind of make it in one slide. So it works the very much same, but it's a little bit more convenient. So you can have a macro that does everything for you. You either create a function accessor that you have a tag, you assign what class you are accessing, what member, in this term, a function, and what is the signature. So return value and the arguments. And for the member is the same. So the tag, the class, the member, and the type of that. And then you have some utility function that will just call the function for you. You don't need to do all of that nasty stuff that looks just terrible and is hard to do. Yeah, you can do it here. And you can just access stuff, see that is returning the std_ref. So you can actually change that and it will still work. So we have the same result. I mean, it is starting with the function and with a little bit different stuff, because that was a live coding. I was really making things up with the names. Yeah, but it works essentially very similar. Yeah, and that is it. There is a link to the library if you'd like to see. That is a hack that was really fascinating to me. And as I said before, there was a guy already that created it, but I didn't know about it by the time. On this library in the README, there is a link to it. And funny to say, there was even a discussion in the Boost. Like I learned that like 2 weeks ago, that they thought about adding that to the Boost. Of course, it was declined because of the many reasons. One of this is ethical. The other is the usage of it. But like 2 years ago, there was a point that people are using that for the serialization and for the Python bindings. So that was cool. Yeah, I didn't know about it either. Yeah. Okay, so that's all from my side. I don't know if you have any questions.
Thank you, Hubert. I have a very quick question uh, just to understand something for myself.
Yep.
Initially when you started writing the code, I think
Yeah.
I'm just curious, like I don't know if we have that now, but it was really in the beginning. You basically used initially in something that calls non-type template parameter, right? When I think in the first wrapper that you had.
Yeah. You said something like let's make it like this. That would be, I don't know, into, right?
Yeah. So this is
This
not
what you
this
mean?
is what we call non-template type
Yeah.
parameter, right?
Yeah.
I don't know if people like it. You usually don't see it in the wild. You usually see template, type name, or class something.
Yeah.
But there is other uh, and today we have concepts, so you can have template, the concept name, space something, which is also another syntax. But
That's true.
templates is a whole.
Crazy.
It's crazy, but it's really powerful and really fun when you get your hands around it. And this is what I really like in this approach, is that you can just for looking at this technique, there's so many concepts to unpack here that is beautiful, in my opinion, just to understand the language. That's the beauty of that. This is why I really like this, at least understanding and I know it might be kind of overwhelming if you see it the first time, but if you look again on the recording and all, that's just to understand every piece of this syntax. It's really powerful. templates are really powerful, and this is why I really like this stuff. So thank you for showing that. Uh,
My pleasure.
let's see if others have any question. Anyone is actually, let me ask that. It's obviously just like Hubert said, it's philosophy. Like, why do you need that and all? And I'm using it in my at work in NVIDIA for testing. For very very specific, just to see something which is kind of a a state that I want to pick, just to make sure that things look okay. But usually I'm looking at the API, but sometimes I want to see something very specific, and this is one of the reasons that I actually need that. Maybe the only reason is that I need sometimes to pick at something just for the sake of understanding, and this is the most proper way, non-intrusive way. Obviously, I never done the undefined, by the way. Never. It was never allowed.
Yeah,
Uh, but I don't know if others have any experience, or maybe they needed that.
I guess no one is heretic right now here.
No one, no one, no one actually understood that this is actually possible. But yeah, this is. Do you have your library in your slides? I'm going to publish the slides like
Yeah,
every month, so you have everything there. Um, by the way, there is, I don't know, Hubert, I don't know if you're familiar with that. There is a paper, not a paper, like a blog post, super old one. Someone is asking something.
yeah.
Uh, oh, someone actually asked the other way around. Can you prevent that? Like, you want to harden your class?
I don't think you can. I mean, I'm not sure if you can that easily because I never thought about it actually, but I'm not sure if you can do that since this is. I'll need to think about it. That's a really good question. For the moment, I don't believe you could do it, but I wouldn't believe about accessing those stuff legally like some years ago either. Uh, so yeah, but I'm afraid it might be hard to prevent from it because then you're just the standard gives you the way to access whatever you want. So it's hard to think of a way to prevent it.
Thank you, Hubert. So I'm going to post something which I just remember that I've seen. This is from 2010. And
Yes,
this
this
is
is
actually,
exactly the blog post that I
that's a
mentioned.
blog post. Okay. So this is
Yes,
this is the first time, this is 2010, that
yeah.
I realized that this is actually possible
But
in a
actually,
standard way.
I understood. I mean, I found out in this Boost mailing list that it is not the first instance
Okay.
of it. So that's the first blog post, but it was in some GCC or client mailing list that someone said, "Hey, that's gonna break." So back like I think I don't know. And I think they mentioned the year, but I can't remember right now. But that was like probably 20 years ago or so. That they said that can be potentially breaking. And about the blog post that you said, yeah, I have a link on the library. Just
Okay.
to be clear, that is not something that I was the first one to use. But I didn't know about it. I learned about it when I pushed the Reddit post like, "Hey, I created a cool library. Take a look. Maybe don't use that too much, but take a look." And they said, "Hey, there is a guy who did it
Yeah.
before you."
Yeah. Nice. And I think this person is ranked really high. I remember seeing that in Stack Overflow.
Yeah,
Uh, so I don't know if he's still active in the C++ community. I don't know about that, but
yeah.
uh, this is
But it's definitely a cool.
It's
cool
cool.
thing. And
Yeah,
he
yeah,
made it, I think, a little bit smaller than I did, but a little less readable, I think.
yeah. And someone is asking if Rust provides additional security for similar instances. So don't you know if Rust has any tricks
As,
like that that are
uh,
needed?
I'm still kind of a novice, but from what I know, Rust don't really care about privacy that much. If you want to access them, that you just access them. So they don't prevent you from doing that. They say you shouldn't, but it's not like you can't.
Yeah.
So they are kind of getting the other way around. Like, you can do it, but you probably shouldn't.
Thank you. Cool. Thanks. If there are no other questions, we'll thank you, Hubert. And
Thank you.
this is awesome. And yeah, see you all next month, hopefully. Thank you so much, Hubert. Have a
Thank
good
you.
good
That was a
morning.
pleasure. Yeah,
It's
yeah.
pleasure here.
It's not late anymore. It's just early.
Take care, Hubert. Thank you so much.
Okay.
Keep in
Thank
touch.
you.
Bye bye.
Have a good one.
Bye bye.